Hi everyone, so we are going to continue with our digestive system here. So just a quick reminder of where we've been already. We started in the mouth or the oral cavity, and we saw some mechanical breakdown with the teeth crushing all that food into smaller pieces, and a little bit of chemical breakdown as well with the salivary glands secreting amylase to help break down those carbohydrates. Then we've moved to the pharynx, where we saw a really important mechanism for swallowing, the epiglottis. And now we are moving down into the esophagus here. So the esophagus is the food passageway from the pharynx to the stomach. It's about 25 centimeters long. And I do want to remind you too, it has smooth muscle tissue that lines it. And that smooth muscle tissue is going to benefit with this peristaltic movement of that food. And then from our esophagus, we'll go through the lower esophageal sphincter, and that's going to connect the esophagus to the stomach. But let's take a look at this peristaltic movement real quick. So again, remember that the esophagus is lined with smooth muscle tissue, so there's kind of a wave of contraction that happens here. So as these little contractions go through, we can see that the food is going to be propelled downwards. This is also the reason that we can eat upside down, because these little contractions are going to push the food towards your stomach no matter what. Which brings us now to the stomach. So the food has been dropped from the esophagus, the lower esophageal sphincter, into our stomach. Our stomach is this J-shaped pouch that contains really thick folds or rugae of mucosal or in submucosal layers. So these mucus layers are going to be really important to protect our stomach from its own stomach acid. It's going to receive that food from the esophagus, and we're going to see a majority of chemical breakdown in our stomach, though we will still see a little bit of mechanical with the contractions of our stomach, but mostly chemical here with all of our gastric juices, that stomach acid starting to break down our food. And they're also going to see protein digestion start here with pepsid. That's another enzyme. This is for protein digestion. And then again, we're taking a look here. It's going to be very limited on absorption. So again, stomach main focus here is going to be digestion, the actual breakdown of the food, not so much absorption just yet. So let's take a look at what this is going to look like. So from the stomach, we're moving into the small intestine. So again, we can see here our esophagus connecting to the stomach at the lower esophageal sphincter. We can see our stomach, this nice J-shaped pouch here with the rugae and mucus layers to help protect our stomach. And then we can move through and see this is the connection to our small intestine at the pyloric sphincter. And that beginning of that small intestine is going to be called the duodenum, and we'll get to that in a little bit. But again, as this food is coming through, we see there's a sphincter at the top and the bottom, and that's going to be really important, and we'll see that in just a second. So now the food has been dropped into the stomach. It is going to be digested chemically with that stomach acid and a little bit of mechanical with these contractions that you can see here. But I do want you to notice that both our sphincters here at the top and the bottom are closed. And you also see this word here, chyme. So our food, once it comes into our stomach, starts turning into this chyme here. So that's what we're going to call it from now on. As soon as we have digested most of the food here, what you're going to notice is that this pyloric sphincter is going to open and allow that chyme to move into the duodenum, where we're going to see a majority of digestion happening in this beginning part of the small intestine. What we're going to see with this duodenum is that we're getting influx from some of our accessory organs to help with that that chemical breakdown of our food. So the food is coming down into our small intestine, into the duodenum. So the first accessory organ that we're going to talk about here is the pancreas. The pancreas is really responsible for most of the chemical digestion. It secretes pancreatic juice, and what's in that pancreatic juice is enzymes to digest all of the different macromolecules that we would find in our food. So carbohydrates, fats, nucleic acids, and proteins. So what that means is that our pancreatic juice really can digest anything you throw at it. So that's why it's really dangerous to have any type of pancreatic leak or pancreatic cancer, because those juices can physically digest your body itself. So it's really important to have a good connection here and not anything wrong with our pancreas. We're also going to see that our pancreatic duct connects to the duodenum directly. So that means all of that digestion with all of these different things here is going to happen in our duodenum, that really beginning part of our small intestine. And it's also going to join with the common bile duct. So then we'll see what that looks like in just a second here. But as that acidic chyme enters the duodenum, remember it's going to be very acidic because of all of our stomach acid. We see secrin, a hormone, being released into the bloodstream, and that hormone is going to help neutralize that acidity so it doesn't damage our small intestine or large intestine. So let's take a look at this. We can see our pancreas. Here's our end of our stomach coming into our very small part of our small intestine here, the duodenum. And our pancreas right here is snuggled right into this curvature. And we can see this duct here is connecting with our bile duct, which is in green, and we have our pancreatic duct in yellow. And that is going to deliver all of those digestive enzymes that we're going to need here into the duodenum, where the food has just entered here. But there are two other accessory organs that we're going to need to talk about here, and that is one of them, the liver. So the liver has two lobes, a right and a left. The right is going to be larger here. And there's two types of cells that we're really going to focus on here, is the Kupffer cells, which are phagocytotic macrophages. So that's a lot of big words. Basically what this means is these little organisms that are going to be eating things to help remove bacteria or foreign particles from our blood. So again, just to help with filtering. But the one for digestion that we're going to take a look at is bile. So bile is a greenish, yellow-green liquid that's going to be secreted by hepatic cells. So what's really important about bile, please add this to your notes, is that it helps digest fats. So that's what's really important about bile, that digestion of those fats. And something that helps with the liver here, if we take a look, is this little organ that kind of hangs behind the liver here called the gallbladder. So let's talk about what the gallbladder does for us. So it's this tiny little pear-shaped sac that's attached to the underside of the liver. And its main job is going to be storing that bile between meals and contracting to release the bile into the small intestine. So when we have our liver here, it's making bile all the time. So once it's made that bile, it needs a place to store it. That is the purpose of our gallbladder here, storing that bile. And we're going to see here that the gallbladder is going to bring that bile to the common bile duct, which connects with our pancreatic duct, that leads into our duodenum. So again, all of those chemically digestive enzymes that we need to break down our food is going to be coming into the duodenum through the pancreatic duct and the common bile duct here. Remember, pancreatic fluid has enzymes for carbohydrates, fats, nucleic acids, and proteins. Here we're going to see mostly bile, which is used for fats. And that's where we're going to end for today. If you have any questions, please let me know.